Hello everyone. In this video, we will be discussing some of the numericals in brakes. We will be discussing all three type of brake problem, that is a band brake problem, block brake problem, and differential band brake problem. So all the three types of cases, the problems we will be discussing. So I'll try to cover minimum 2 to 3 problems in each video as we discussed the design concept previously. So it's all about what is the right formula to be chosen and how to do the calculation and how to present the final answer. So there will not be any difficulties in the calculation part. So the only difficulty probably would be choosing the selecting the right formula for that one. And all the problems whatever I'll be discussing in breaks, I have taken the questions from the VTU prescribed textbook, design of machine elements, authored by VB Bandhari. So the first problem, where we will start with the block type handbrake, and even when we discuss the concept also, this was the first type we have discussed. So the block band type, where it is shown in the sketch, both the sketches they have shown, has a face width of 45 mm. So face width value they have given 45 mm. So width, we will be writing the face width as what here, width. The friction material permits a maximum pressure of 0.6 megapascal. So the pressure value is 0.6 megapascal and the coefficient of friction is 0.24. So mu value is 0.24. And when we and other what we need to find out means, we need to find out number one, effort, number two, maximum torque, number three, heat generated if the speed of the drum is 100 rpm and the brake is applied for 5 seconds at full capacity to bring out the shaft to stop. So diameter they have given 100 means, sorry, speed they have given 100 means, let me denote it as n is at 100 rpm, and the diameter they mentioned it as 300. You can able to see the sketch where the diameter of the brake drum, it is 300, and the angle of contact, it is 90 degree, that is 2 theta value. Hope you remember. So whenever when we solve this one, if the 2 theta is greater than 60 degree means we need to go with the equivalent coefficient of friction. Okay, so since the t theta is 2 theta is greater than 60, instead of normal coefficient of friction, we should go with equivalent coefficient of friction with the note formula, mu dash, which is equal to mu into 4 sine theta divided by 2 theta plus sine 2 theta. So here the angle of theta is 90, 2 theta is 90 degree, so theta would be 45 degree. So mu, that is 0.24 into 4 of sine 45 degree divided by 2 theta, since it is in degrees, convert into radians. So 90 into pi by 180 plus the sine of 2 theta, so sine of 90. So after simplification, we will be getting the equivalent coefficient of friction mu dash as 0.264. Then moving to the next one, allowable pressure, the formula is P is equal to Fn divided by 2Wr sine theta. So we know the P value and we know W face width value and we know the radius of the drum and even angle also we know that. So here only Fn is the unknown. So Fn I can able to find out from the simplification, that is 5727.56 Newton. It is a normal force. And tangential forces, F theta is nothing but equivalent coefficient of friction into normal force, or like T1 minus T2 into Fn also we can write down. So anything is fine. So equivalent coefficient of friction value is 0.264 and normal force is 5727.56. So it is 1512.1 Newton. And for the various forces acting on the shoe are shown in the sketch 3.11b. You can able to see these are the various forces which is acting. So from the sketch I will be writing down A value 200, B 300, and we don't have center distance for this case because on the same axis only the tangential force is following, it is moving. So the tangential force F theta passes through the fulcrum, so C is equal to 0. So for this case, F is equal to F theta A divided by mu dash into A plus B. So this is F theta value A and B value, if you are substituting means I am getting the effort value, it is 2291.1 Newton. And the torque on the drum M1, the formula is F theta R. So both F theta and R is known, that is 1512.1 into 150. So it is 226.815 Newton meter, or else 226815 Newton mm. Power absorbed, that is N is equal to M1N divided by 9550. So from this power I can able to find out the value is 2.375 kilowatts. And finally the heat generated during 5 seconds is the power absorbed into the number of time duration, that is 5 into 2.375, it is 11.875 kilojoules. So this is the first problem answer. And moving to the problem 2, a single block brake is having the diameter of the drum is 300 mm and the angle of contact is 900. If the operating force of 600 Newton is applied at the end of a lever and the coefficient of friction between the drum and lining is 0.3, determine the torque that may be transferred by the block brake. So it is like a previous problem. It is also a block problem. So same formulas whatever we discussed, the same thing we can use it here also. And the given data, L is 550, that is length of the lever, and here we have the A value, B value and all. So we can write down that is x is equal to 250 mm, A 550 mm, R is 2 theta and 90 degree, which is equal to pi by 2 of radians, and F is equal to 600 Newton, that is applied force, and coefficient of friction is 0.3. So in the present case, the angle of contact is greater than 60 degrees. So as usual, I will be going with what? Equivalent coefficient of friction like previous problem. The formula is mu dash is equal to 4 mu sine theta divided by 2 theta plus sine 2 theta. Substituting the degree to radian conversion, I will be getting the equivalent coefficient of friction value is 0.33, and taking moments about fulcrum O, where I will be getting the value as reaction Rn into mu dash is equal to Ff. So Rn is equal to, I can write as it is Ff divided by mu dash. So from this I can find it out. Ff value as 466.4 Newton. And torque transmitted by the brake Tf is equal to Tf into R. So the value is I am getting as 70 Newton per meter or 17 to 10 power 3 Newton mm. And moving to the third one, a band brake problem. So this is second type of like a design we discussed in the brake. So the question is, in a band brake, the band is wrapped on the 3/4 of the circumference of the brake drum. The diameter of the brake drum is 500 mm. The band brake provides a braking torque of 355 Newton meter. So one end of the band is attached to a fulcrum pin of the lever and other end to a pin 150 mm from the fulcrum. A force is applied on the lever at a distance of 600 mm from the fulcrum. The coefficient of friction is 0.35. Find the force applied on the end of the lever when the drum rotates in the anti-clockwise direction and clockwise direction. So write down the given data. So we need to find out what is the applied force at the end of the lever, that we need to find out. Coefficient of friction is 0.35. So angle of lap on the band on the brake drum, that is a 3/4 of the total angle 360. So it is 270 degree. And radius of the brake drum, it is 250 mm. So 0.250 meter. And L is nothing but the perpendicular distance between the fulcrum and the force m, that is 600 mm, and the braking torque, it is 355 Newton meter. Y, the distance between the pin to which the other end of the band is attached and the fulcrum, that is 0.150 m. Or we can write in terms of mm also. So the same thing whatever they have mentioned here in the sketch also they have shown. So let me go with the first tension formula, that is T1 by T2 is equal to e power mu theta, where theta is nothing but in terms of radians, that is 4.713 radians, just by multiplying pi by 180 with the given angle. And we will be getting T1 by T2 as since coefficient of friction is known, so T1 by T2 is nothing but 5.2046. So I'll be writing the T1 in terms of T2. And I know the one more formula, tension of the band TB is equal to T1 minus T2 into R. So here I will be substituting the T1 value in terms of the T2. So T1 minus T2 I will be getting 1430. By equating this equation 2 and 4, I will be getting the T1 and T2 value as T1 as 1757.7 Newton and T2 as 337.72 Newton. So we have two cases, that is drum rotates in the anti-clockwise direction and drum rotates in clockwise direction. So for the anti-clockwise direction, take moment about O. So it is T2 into 0.150 is equal to F into 0.60. So while solving, we will be getting F as 84.43. And in case of the clockwise direction, it is T1 into 0.150, which is equal to F into 0.60. After solving, we will be getting the F value as 439.43. So in this case, we can just say that the more force is applied during the clockwise direction of brake wheel rotation. So we will discuss few more problems in the brakes in the next video. Thank you.